Hello, Professor.
Can people hear? Good. All right. I just did a whole bunch, but I don't think you heard them. I will do them again. There's a device problem, as you can gather, but can I just start by just asking, can you guys hear me? Oh, wait.
Yes, we
Is
could hear you.
Yes,
yeah,
Professor.
okay. Thank you. Thank you. Okay. Now you can hear me. Okay. All right. So let me start. Well, let me. All right. Well, first of all, good afternoon, Avani. Good afternoon, Hayu. Good afternoon, Freddie. Good afternoon, Matthew. Good afternoon, Marilyn. Good afternoon, Melita. Good afternoon, Yiyun. Good afternoon. Sorry. Oh, and thank you, Matthew. Oh, okay, okay. And good afternoon, Christopher. And good afternoon, Elweli. Okay, awesome. All right. So this is, as you can see, we're having a technical. Well, can you also can I ask? Although this is not going to be true, can you? Oh my gosh. Okay. Can you see me? That's a
Yeah, we
yes.
can see you.
Oh, thank you. All right. And that was a Michelle. And I see Michelle. Thank you. Okay. And I heard Melita. Okay. Thank you. And thank you, Yoon. Okay. So we're operating on very low octane fuel here today. I apologize. We're going to get rolling in a second. We're going to have class. Of course, we're going to go over things, hopefully helpful. But number one, my computer, just to be honest, just so you understand, I don't have my computer. My computer was brought into the repair shop on Friday on the assumption that I was going to get it back on Friday. And it is still there. And they lent me some the computer. How old am I? Computer repair shop. I sound like I'm in 1930, whatever. But what I didn't do was bring it to an Apple store, which I should have done. Anyway, the point is they lent me a tablet to get through. And it's not, I'm not complaining. They're being very nice, but I am complaining because between me right now and the hardware that I'm using, this is not quite the way we usually do things. But anyway, we're gonna do them. But I'm apologizing. Basically, what I'm apologizing for is in a minute when I switch to the screen, when I start going over notes and everything with you guys. Oh, hello, Christopher. Okay, awesome. Or yes, hello. Okay. When I start going over things in a minute, like on the screen, I think I'm going to be using the exact same device to do that. So I think I will disappear, which maybe doesn't affect you very much. And I mean, my voice won't. I think my face will. That probably bothers me more than it bothers you, maybe, but it bothers me in terms of the hypocrisy because I keep encouraging you guys and giving you points and great acknowledgement. For example, Michelle and Christopher, like I really appreciate the effort that people go to show video and stuff. And then today I'm going to be one of those people that literally will fail to do so once I start, because I do think that the notes are more important than my face, but maybe I'm even wrong about that. All right. Anyway, uh, the notes will definitely be uploaded when the class is over. In fact, I think they actually already were uploaded sort of by accident, so they're there. So you'll definitely get the notes from everything today. Oh, hello, Melita. I really appreciate it. Okay, hello. And this is being recorded for what it's worth, as whatever this is today is being recorded, although it's being recorded in a funny place. So I hope I'll be able to retrieve it when it's all over. If I can't retrieve the recording and upload it, I will upload, or I'll direct your attention to a similar class from a recent semester just so you have something. But I'm just warning you, the recording might not work. So it might be all the more reason to, I don't know what, to take notes or whatever today, or to record on your side if you're allowed to do that. I don't know. Okay. As usual, for certainly whatever questions you have, I'd like to make the priority. I'll give you the agenda, the general agenda, and then we'll switch screens. So, or the general situation. Oh, and there's Cheska. Thank you so much for showing video. I totally appreciate it. Okay. And hello. Hello. Awesome. Okay. Wait, who else did I? And if I didn't say hello to Giselle and Amanda, I apologize. Hello, hello. I'm glad you're here. I apologize that today's like a slightly weird class because I'm uh, like I'm not up. There's hardware issues, and then there's 52-year-old man body issues. That sounded weirder than I meant. Okay. I just mean I'm sick. All right, all right. So number one, homework. No, yes, homework number one, number line. Right. That was like in theory due last week, and tons you handed in when you were supposed to, which I really appreciated. And as you all know, anybody who even handed it in on time and handed in anything like remotely thorough looking, first of all, just got 15 points right away as an acknowledgement of that, like 15 out of the 20. You know that. Then, so that's good. Then, then I went back. Hopefully, you saw. I believe that every single one of you who turned it in has now received, like, I think fairly extensive feedback from me on what you did. Um, um, so I want to spend a little time today talking about that feedback or what to do with it, or and blah blah blah. And let me say again, I know these first couple of classes are kind of ramp up classes. They'll get maybe less boring, but also more challenging. Maybe they start moving faster as the semester goes. But in the first few classes, I want to make clear again that homework one is designed, it's not meant to be that super stressful to see how to get the answers for most of the questions. Like, and again, don't take that the wrong way. If you did find it stressful, I don't mean that doesn't mean you're like a bad person or something, or not, or you don't belong here. But my experience is that for a lot of you, getting to the answers for a lot of the questions in homework one, someone's here, doesn't really get taxing or stressful until like part three. Then on part three, let me just say right now, a lot of people got right answers, which I find very impressive because I think you did have to think, but a lot of people got right answers. A lot of people did a bunch of stuff for part three or whatever, the final part of homework one. A lot of people did a bunch of stuff that was very thoughtful and responsible, but then landed on incorrect answers. That which is no shame. And again, you could still get full credit. You could potentially still get full credit for the whole thing, even if you're wrong answers. And you definitely should not be ashamed of yourself. And you definitely should not be worried. If it turns out that you got wrong answers to the last couple of questions on no, do not think that means you don't belong here or something like that. It means like, okay, good. Like it'll be worth it for you to be here. And we'll start having some things to discuss and give you your money's worth. Like seriously. However, the reason and then some of you, people fall in all different places. What I'm really trying to say is homework one, the substance of it is not designed to give you a heart attack. It's not designed to crush you or anything like that. But it's designed so that if most people can sort of follow most of the answers, at least while we talk about them, then it's an opportunity to really drill down, on the minutia of the 5-step method, even though, again, I know that will annoy many of you, and it'll particularly annoy those of you who think you have the right answers already, or who do have the right. We're here today. When I go turn back to it, we're here today to get to try and to get as much feedback as we can and as much practice as we can right at the beginning of the semester with how to do physics before the physics gets too challenging. And again, I have to say that carefully because it might already be challenging for some people, and that's fine. Wait, control your camera. Yeah. Wait, you can do that? Sure. Hold on a second. I've never heard of that. Wait. Okay, I'm going to give this a shot. If that works, that's amazing. Okay, hold on a second. So that means, wow. I'm like, okay, and I'm going to just keep talking, and I'm going to assume that, oh, hello, Yoon, very good to see you. And I will get to physics in a second. I'm just sort of apologizing as usual, defending myself that we're intentionally trying to make your 5-step method program like very kind of overly intense right now, while the physics might not be that crazy hard for at least some of you. The thing to focus on is a 5-step method and all those details, because again, it's, if nothing else, it's all preparation for the exams, where that's like literally how I grade them is the 5-step method. Okay. So I really want, even if you hate it by the time you get to exam, at least you won't be surprised by it, or you won't yeah, at least you won't be surprised by it. So, okay. All of this is to say, you got feedback on on homework 1. If you got, hopefully you should read all my comments. You should read the comments. If you have handwriting issues, you should let me know. Most of my comments are like acronyms like GDP, PAW. You should start to learn what those acronyms mean. Those are the 5 steps. That's what it's all about. Again, you'll see that even if you got a lot of right answers, if you never put down what a WIQ, if you never wrote what the question was for each question, as annoying as that is to you right now, it's like super important to me and will be on the exams. You got to get in the habit of making the question clear. So you can see you can get right answers and still not get full credit, just like you can have all wrong answers and get full credit. So anyway, look at the comments. If you got, honestly, if you got a 16 on the homework, that's totally fine. It means you're in the right place. It means you're totally doing the right thing. But it means actually that I'm definitely bringing your attention. It means it means I've looked at it if you got a 16, like, and I looked at it carefully. It means I'm trying to draw your attention to the fact that some big steps are missing somewhat frequently. And you can and should resubmit if you want all the 20 points. Now, again, honestly, even if you end up with keeping the 16, it's fine. You're going to do fine in the class if all your grades look like that. Like, it's totally fine. But you can, there's no time limit. You can resubmit and go for until you get a 20. You can. Um, and I think if you got a 16, you might want to do that just for the practice, because it means there's something you need to practice for the exam. If you got uh, a 20, definitely make sure there's any comments that I made that you might want to just register. But if you got a 20, it means you know this is what you need to be doing. Great, good, we're solid, awesome. If you got a 19, I mean, to be super, I'm just trying to be thorough. I won't be this thorough on every single homework. I won't give you this much feedback, honestly, on every homework. And I won't talk about all these, but I want to get this all straight at the beginning of the semester. If you got a 19, it means you totally know what you're doing. Yes, you are doing the steps. Yay. Like, I follow your work. It's clear. It's great presentation. You probably got a lot of right answers too. But if you got if you got a 19, you could totally keep it and it would be fine. Like, you don't need to kill yourself for 1 extra point. But if I gave you a 19, it's to signal you that you should at least really read my feedback and make sure you know why you didn't get a 20, because whatever it is you're missing, you definitely need to get in the habit of doing. Again, maybe for the exam. So don't kill yourself over the grade. If it's a 19, it's fine. It's up to you. But at least it means there's something okay, I think you understand that. And anything in between, maybe you want to redo. You have infinite time to redo it if you want. I hope that's clear. With the other homeworks now, let me just get it. And if there are any questions about anything I'm saying, is that camera thing really working? I'm so impressed by that idea. I just like, wow, okay. I think they designed it for like spazzes such as myself. The other homeworks, just to be clear, because I'm also just trying to address a lot of things that I got from like a lot of emails and texts. So I just want to try to address them right here. And the homeworks were good. They're very responsible. Like, again, if I thought someone was in the wrong place, I would start thinking about reaching out to that person. I don't think that's the deal with any of you. Um, um, Wait, sorry. Let me stay on homework 1 for a second because I just remember a couple things. You can look up, or you eventually better know what like I mean by DFP, WIQ, GDP. We'll talk a lot about GDPs today. But a couple more pieces of notation that I use in the grading, in the homework, in the exams that maybe you should jot down right now. I can't really jot down because of the board situation. A couple more like abbreviations you want to be aware of. If I write FAC, okay, which is step 5, right? FAC is final answer circled. If I write that and then I put an equal sign after it, okay, that's very ambiguous unless I explain it. What I'm getting at with that is another very picky thing. With final answer circled, okay, I do need the final answer. I need a final answer. I need it to be denoted somehow. I'm not saying it literally has to be a circle. It could be a highlight. It could be boldface. I mean, but it has to be clear that you know that it is the answer. Okay, but now here's the equal sign part. It has to tie back. The whole idea of your work is that your last step has to tie back to your second step where you laid out what the question was, like in your words, right? Very important, super important for research. I can't tell you how I learned this so the hard way in the second time I was in graduate school. Like for research, it's shockingly important to be like, here is the question. Here is the answer to the question that I posed. Like it's really important that the two match, like in a big way. It's important for a million reasons, and it's much, much easier said than done. It sounds like such a stupid kindergarten instruction, but it's actually really hard to do really well because it's actually really hard to actually know what it is you're trying to do when you're doing it. It's really easy to lose the forest for the trees as a writer and as a reader. So anyway, so your job in step two, the job that everybody hates to do at this point in the semester, but your job in step two is to be like at t equals 4 v equals question mark, or like whatever, like not to copy my words, but to like use your own words to make them even shorter and sweeter, to say the question, and to like lay out the condition in the question, like again, so clearly, so concisely, but so clearly that anybody reading your work doesn't need any other document to reference when they're reading your work. Right? It's physics work on its own. It could be published. Then in step 5, okay, here's where I'm trying to get at with this. Step 5, when you get to the final answer, like, first of all, yes, you have to circle it or bold it because we have to know this isn't just like raw information somewhere. We have to know you feel like this is the landing place, like you, boom. But then also, it's got to be a complete thought. I've noticed this in a lot of people's work. Your final answer can't be 3 meters per second. Like, that's not actually an answer. I mean, that's a fragment of an answer. Like, an answer, if the question is, what is V at t equals 7? Then the answer is at t equals 7, v equals 3 meters per second. In other words, and I know this all sounds very picky, and I feel, I mean, even listening to myself, I want to puke, believe me. But it's from my experience that this really actually is one of the differences that makes a difference. Your final answer, what I'm trying to say, taking way too long to say, is your final answer has to be an equation. It has to be an equation. It has to be an equation. It can't be a number. It has to be something like at v equals 3 meters per second. And one of many reasons for that we're going to get into is I want you to see equation doesn't mean formula. I'm not saying that your final answer to every question is some new recipe that is going to be published in a chemistry textbook that everybody's going to look up on the back page. And like, it's not a formula. It's an equation. It's not a triple equal sign. It's a double equal sign. You're saying that you discovered that this measurement under this condition yields this value. Like, and that's what it needs to be. Okay, I've said too much. But so if I ever write FAC equal sign, I'm saying, wait, I see your answer. I see it circled. I even see it's probably a right answer, but I need it to be a complete thought. I need it to explicitly tie back to question 2. I need it to have an equal sign in it. Okay, that's all. All right, just so you know. Okay, again, there's a lot of people that probably got a 19 that were missing that all over the place, and that's all they were missing. So they got a 19 instead of 20, just so that they know that that's what I'm. You get my point. I'll shut up. Okay, that's that. And again, you could stop me with questions at any time. Right. So other pieces. So that's what FAC equal sign means if I write it. Another thing, if I ever write BCF on your home or on anything, if I ever write BCF, that means be careful. I don't know why, but it does, or in my head it does. BCF means be careful. So it probably means you're doing the procedures correctly and you're a responsible person, but actually you probably made a fundamental misunderstanding in one of your GDPs. Like, you might have written a GDP like average velocity means blah, 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 but actually you don't seem to actually understand what it is, or you used or something. Anyway, it means be careful. Now, last thing, I really will go on. I'm boring myself, but the last piece of notation that I use a lot, and I don't think I used it on any of your homeworks yet, which is a good thing, but it does happen on exams. If you ever see, and this is like the danger, Will Robinson thing. If I ever write WWW, on anything, but especially on an exam. Okay, what that mean? I'll say it again, www. Okay, it's not in any. I'm just telling you. If I say www, it means like what, why, where is this from? And what that is my most polite sort of first chance, first warning way of saying, whoa, your physics just took a left turn that's a little suspicious. It means you just wrote down some physics that might be an equation or something, right? Might be like a GDP or something, and it might be correct. In fact, often it probably is correct, but it seems like it suddenly came out of nowhere. Like it doesn't seem to have followed what you were writing before. It doesn't seem like you're explaining it in any way. It doesn't, and often it might not be something that we've even talked about in class. So, like, ding, 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 what it means is I feel like you just wrote down something that you got from the web. And let me use this little opportunity to clarify, you're totally allowed to use the web. You're encouraged to use the web. Please use the web, and like all in all of its glory, and especially on homework. Of course, you're allowed to learn things on and find, but when you have to use, and you're even allowed to do it on tests, on exams. But the thing I want to warn you about now, before anybody gets hurt, like because nobody's made this mistake yet, so I'm telling you now while it's safe, you use the web to learn. You use the web to to clarify equations that you don't understand and blah, blah, blah. But if you grab something from the web and then you just basically what I'm saying is you can't write down things that you don't understand. The main purpose of the 5-step method is to force us all to break everything down so that everything we're writing follows from everything we wrote before. And we're showing that anything we put on paper, we might not have made up. Someone else might have told us. We might have watched a video, but we now get. Like that is the ultimate standard of non-cheating or cheating in this class, is that whenever we write down, we could defend, we understand. So if I ever write www, that is a signal that I'm saying, I think there's something here that is out of left field and that you're just writing down because you think it's going to help. And I'm going to watch carefully now if you explain it or not, or how you use it. And I'm going to be a careful eye on the rest of the document to see what's going on in this document. Like it basically means I'm now watching carefully to see if you really understand what you're doing, or you're just taking chunks of knowledge from various places and trying to string them together. And anyway, I don't want to be negative. I'm saying it intentionally, but it's always an issue every semester, especially with the kind of exams that we do here. It's usually a low percentage of people, but it happens. So I'm just alerting you now before it's happened. That's what www means. We're on shaky ground and we better get off that ground fast. Okay. All right. That's a negative thing. And it doesn't apply to anybody here so far that I see. Oh, and it's great to see you and Amanda. Hello, Jessica. Okay. I'm boring the crap out of everybody, including myself. Okay. Oh, sorry, but there's one more bookkeeping thing. And again, you could stop me. You could totally in chat be like, yeah, we get it. We get it. Please go on. Please take a cup of coffee, yeah, but other logistical things. But this is mostly meant as praise. Like I think you totally are in it to win it here so far, and you're doing all the work. So speaking of the work too, you've all gotten back number line. You've gotten it with comments. You can redo it and get a perfect score. We've said that. What about the other homeworks? Now the other homeworks, number 2 and number 3 were due today. They were just literally due now, so I haven't sent them back to you yet or anything like that. Let me clarify. 2 starts to get harder. You might have noticed it's no new concept at all, but it really forces you to really take the definition of average speed seriously, just as a word to the wise. I hope it wasn't too stressful to do, but to get the last 2 questions correct does take some work. Like a lot, just as a warning, a lot of people might have found the last 2 questions on homework 2 like easy to do, but that doesn't necessarily guarantee they got the right answer. That's just a word. So I don't know if that means whatever. But question 2, I did expect the 5-step method. Question 2, I will get to next, when this class is over. It's not any new concept. That's all homework 2. I'm sorry. Homework 3 was a left turn. I got a lot of emails about it, a lot of questions. It can be very confusing. If homework 3, we're going to totally discuss in class. Homework 3 is a very different kind of homework. Most of our homeworks will never look like that. And most of our exams mostly don't look like that, mostly. It's very conceptual. It's not numerical. That means it's very important. It's super important, but it's very different. I know that. So 2 things about homework 3, even though, technically it was due today, but Number one, you were not expected to do the 5-step method for it. You were not. It's one of the rare cases. I think it said that somewhere in the classroom. You were not supposed to do 5-step method for homework 3. You were just supposed to do it. Number two, if you're not thrown by if you understand that it's different, that it's a different kind of assignment, it's conceptual, ideally you would be relaxed with it and almost maybe sort of have fun with it. I'm telling you right now, if you haven't done it yet, or you're late, or you're revising it, that one I'm not grading for methods or steps or anything. I'm just looking to make sure you like did it all. You'll get perfect score on that if you just did it and you took it seriously and you did the diagrams and whatnot. We'll talk about the purpose of it in class when we get to it, but don't stress that one. Just think about it because it's, I think, worth thinking about. All right, that's the ones here. Homework 4 has now been posted. That's not due Monday, it's due Wednesday, because for sure now, if you look at homework 4, you will see we're starting to get into real physics by homework 4. Like, it will require thought. If you try to do homework 4 right now, you might, based on just what we've said in class, you might start getting stressed. You might start getting angry at yourself, or more likely at me. I would totally understand that. But we're going to be rolling by the time we get to homework 4. We're going to have a lot more concepts laid out, and we're going to be moving a lot faster. I'm asking you right now just to try your best. Look up whatever you think you need to look up. But again, there technically, anything you need technically there was either established in the prior homeworks like we're about to do now, or it's actually explained in the sheet. Technically, if you're just thinking very carefully and following the logic of definitions of this class, technically you shouldn't have to look anywhere to do it, but you can, and it is hard, and you don't have till next Monday, you have till next Wednesday, so we'll have time to talk more before we get there. Last thing, with all of these homeworks, right now we're still at a stage, not only can you do infinite revisions, but if you're late, that's just going to mess you up more than it's going to mess your score up. Like if you're late, it's more of a chance you're going to start falling behind, especially with homework 4. Like you don't really want to be behind by the time you get to homework 4, but I will accept late homeworks at this stage. I will. And everybody still has a chance to do perfectly on everything at this stage because I'm taking so long to explain everything. How could I not? I will let you know once deadlines start meaning something more, and they certainly do on exams. But right now, if there's something you haven't done, just do it and do things in order. And I'm going to shut up now about all this. It's driving me crazy. I'm going to move now I'm going to switch. If there's no questions, I'm going to move to continuing to go over homework 1 number line. Like I think we got to 1 question of it last time, and now we're up to question 2. Is that okay? So is that correct? Yeah. Thank you, Amanda.
Yeah, that's correct.
Thank you. All right. Oh, and thank you, Michelle. And thank you guys for not like literally like being dead on the floor right now okay. All right, cool. So yes, so I'm going to switch the board to the notes, which means I think I'm about to disappear. You're just going to get a board on here. Bear with me for a second. I think that's how it's going to work. I don't know why that happened. All right. Drop dead. Wait. Oh, there's stuff in the chat that I missed this whole time. I'm sorry. Wait. I think someone just told me to drop dead. Oh, proceed. We get it.
No, he's saying because your video goes out.
Sorry. Okay. Oh my God, that's hilarious. Okay. No, you guys are very good people. You're very understanding. Okay. I'm going to now share the. Okay. So I can no longer see you at all, but you can see, just look with your voice, tell me, you can see like a board.
Yeah, we could see the screen.
Yes, we could see it.
Great. All right. Thank you. All right. Awesome. Okay. So here we go. I'm just going to get rolling. I mean, these are equations I want to start discussing today. We'll see if we do, but let's just get rolling. All right. So here we go. Homework 1, number line, continue with question 2. Okay, so there's my diagram, right? Step 1, DFP. And I made the important fact, I jotted down the important fact that every single one of those motions is at constant speed. Okay, so question 2. So now I'm doing, I should write. So this is now step 2, right? What is the question? Okay, so the question is from t equals 0 to t equals 8, what is the total displacement, right? Okay. Here's what I'm going to do. I'm going to try to make this less confusing than I did in the other class. What I'm going to do right now is just, first I'm going to finish. I have a lot, believe me or not, I actually have a lot to say, but I want to sort of get to answers and procedures to you guys. So first what I'm going to do is I'm going to skip ahead a few pages just to make this a little bit more clear. I'm going to skip, that was step 2, right? So I'm going to skip straight. I'm going to skip here to step 3. Okay. Step 3 is GDP, general definitions and principles. And I'm going to write down my GDP for this. Okay. I'm walking around now because I'm paced. This is so weird. Okay. Sorry. Anyway, I'm going to write down my GDP is display. Remember, they're asking for displacement, right? So I'm writing down a definition for displacement. I'm writing down a definition that says displacement is x minus x naught. Now, that that means current position or some current, or you might call final position, minus some earlier or initial position. I'm actually going to more elaborately explain this notation in a moment, but for right now, just so that we can start making tracks on the homework, I'm going to say, because I want to start converting all this English into mathematical symbols and mathematical equations, like so we can really start moving. And if you looked up something like displacement on the web or something, you might find something like this, like x minus x naught, or you might find something, or in an old textbook, you might find something like x sub f minus x sub I, like final x value minus initial x value. There's different ways of writing this. This is the way I'm going to write it. I'm going to explain why in a few minutes. But the key point is that what displacement is a difference between two positions. And as we're going to discuss in a minute, displacement takes into it's displacement. It's how much something was displaced from then to now, how much it moved in space. And it does take into account direction, as the sheet explained. A displacement, as we're going to discuss, can be positive or negative because these x values that we're going to plug in could be positive or negative. So, but anyway, just as far as doing the homework, I would write down like displacement triple equal sign x minus x naught. And then step 4, which is PAW, particular application and work. Now I generally signal to myself and to you guys, I'll generally signal that I'm now getting into the particular work by writing the word here. Like, in other words, displacement in general equals x minus x naught. But here, the values are that x equals -5 and x naught equals +4. Oh, that thing x sub 0 is called x naught. Again, I'm going to explain that in more detail in a second, but I'm just trying to get something concrete on the page for you first. So I do all the work. X minus x naught equals -5 minus 4, and I get -9. Okay, right? Like, so where the guy ended up at the end of all the 8 seconds was at the position -5, where he started at the beginning of all the 8 seconds was +4. So the displacement's -9. So then I go to the next page. So now step 5, FAC, this is kind of what I was yammering about before. Step 5, final answer circled, is from t equals 0 to t equals 8, x minus x naught, the displacement, equals -9 feet. That is a complete thought. That's a complete statement. That is my answer to question 2. Okay. Now, and again, of course, a lot of people got it right, and I'm glad. I mean, and if there is any, it's hard for me to see the chat in this way that I'm doing this. So definitely just like shout or something, but not everybody got this right. And again, I'm not saying that to shame anybody, but if it's like you didn't get it then, but you get it now, great, and we'll move on. But if you still don't get it, there's no shame. You can send me a direct chat or something like that. Like we do, this is the time to get these things straight. And please remember that I know all of you are coming from totally different backgrounds in physics and calculus. I mean, I know what the requirements are, but I also know what that means realistically. So nobody should be embarrassed about asking questions if they want to ask them privately to me at this stage. Anyway, all right, but that's the answer. The answer is that the displacement for the whole journey is -9 feet. Notice it's smaller than the total distance, which was like 21 feet. And notice it could be negative, whereas the distance never could be negative. All right, now I'm going to back up now. That was question 2. Of course, we want to move on, and we will. We want to start going sort of more quickly through question 3 and question 4. Oh, yeah, in question 3, I'm just, in the effort to sort of speed up, I think you get the 5-step method now. It's not the last time I'm going to like walk through all of it in class, but sometimes for efficiency's sake here, like on question 3, I think you see how to do the 5-step method. So I'm just telling you, If you got 21 feet over 8 seconds for question 3, then I totally agree with you. You could leave it as a fraction. I don't care at this stage. If you turned it into like 2.625 or something like that, or something, that's great too, and that's all fully correct. Or 2. Yeah, whatever. 3.37, whatever. That's fine. Then question 4. Question 4 asks for the average velocity for the whole thing. And that's where we start really getting into physics and equations. Like, I'm going to start you off with question 4 and say, and again, I'm skipping steps here, right? These are like, I'm just jotting down things I want you to know now. I'm not doing the, if that's confusing, please let me know. But I'm not walking through all the 5 steps right now because we're trying to catch up with ourselves. But for question 4, the question was, what is the average velocity for the entire 8-second journey? The GDP to write down there is that average velocity is defined to be displacement over time. But now that's starting really to, an average velocity is V with a bar over it. Now that's starting to really look like an equation now. And it is. And it's not a coincidence that I didn't really use any equation for average speed, but I'm starting to now that we're into average velocity. The fact of the matter is the quantities that care about direction are ultimately the quantities we really do care about in physics, and we get very precise and very mathematical about. So most of our equations are, someone's here. How can I let her in? Hold on. See, I don't know how to, hold on. Most of our equations and our symbols really refer to the quantities that have direction. So now we're not reading more. What happened? Wait. Okay. So what I want, okay, not what I wanted to do. Okay. So what I want to do now is slow down a little bit. Before we go any further with these questions, I want to expand on, I want to start building notation and equations. If for no other reason, so that you actually start having things to write down for your GDP, for your step 3s and all these problems. So I'm going to go back. Sorry. Yeah. So this is all, so this is like class notes now. Okay. Like I'm off the page in effect. If this is all like the summary of this is like introduction to notation, symbols and equations. So first, and wait, tell me again, you can see the board right now, right? Like the board is, like you can see a thing that's a scalar
Yes.
quantity. Yes. Okay, great. Okay. So first let's get straight. There's 2 kind of quantities in physics. There's scalar, what we call scalar quantities, and there's vector quantities. Scalar quantities are pure sizes or pure magnitudes. They are numbers. They simply indicate the scale of a measurement, like how big it is. Vector quantities have scale and direction. Generally speaking, these two, like there's like a match between, like for every vector quantity there is in physics, there is a corresponding scalar quantity, because every vector quantity has 2 pieces of information it's indicating, size and direction. So the size of any given vector quantity generally has its own name, and can be sometimes treated by itself. So what we have here, for example, is we have the vector quantity of displacement. That is how far you go from one place to another and in what direction. But the magnitude of the vector quantity known as displacement, of the vector quantity known as displacement, the magnitude of it is known as distance. So like, so they relate to each other. Similarly, if you want to start now relating space to time, and you want to ask how far did somebody get in a certain direction per a certain amount of time, then you're making a ratio. You're dividing displacement by time, and you're calling it average velocity. And and that takes into account size and direction. So technically speaking, I'm reading right to left here. Average speed is the magnitude of the vector quantity known as average velocity. Okay. Notice one of the, and there's many others. I mean, we're going to develop them all in physics. I mean, there's like acceleration, force, etc. But these are the ones we're dealing with right now. Notice one thing before I go on. I'm literally right now saying that average velocity is defined to be displacement over time. It's a triple equal sign. That's super important, like especially because this is going to be kind of our first big equation, and we're going to use it more than you might imagine, you might guess. Note right from the get-go, the reason this equation is correct is because we say it's correct. It was right. If it's correct at all, it's correct all the time. It's correct not because we ever discovered it in a lab, and we can never undiscover it in a lab. It's correct because we're literally saying from now on, the ratio of displacement per time, how far you get in a certain amount of time is such an important ratio. It indicates so much about motion in the universe that we want a word for it so that we don't have to say all of those words every time. So from here on in, whenever we say average velocity, we mean total displacement covered per total time. And it's that straightforward. You will see. And similarly, average speed is defined to be distance over time. The whole purpose of homework 2 that I know you've already turned in, but if this means anything to you, maybe the whole purpose of homework 2 is to practice that specifically with average speed, but particularly by the time you get to the last 2 questions of homework 2, what it's really trying to show you is how seriously we have to take that definition. It's really trying to show you that average speed is always distance divided by time, even when that seems really inconvenient to use, or even when we don't think we have all the information to do that. That what average speed is the average of some speeds. Like, I haven't looked at your homework yet. I'm just saying from experience and without shame that many people, when they get to the last 2 questions of homework 2, they often will take some numbers and average them up together to get an answer. Like maybe they take like 40, like for Grandma Grimm, maybe they take the number 40 and they average it with the number 60 so that they get an average speed of 50. Some people do this. Seems very reasonable. But I am warning you right now, or I'm just trying to say, actually, no one ever said that was the definition of average speed. The definition of average speed is not average of speeds. It's distance over time. And that's the thing that should always work. So just like, I don't know if we'll see when we get there on Monday, but I don't think the answer to the Grandma Grimm problem is actually 50. I guess I'm just saying as a spoiler alert. So just to reinforce, definitions are that reliable. Once we have a definition, if it's true at all, it's always true. And it's always the first thing that we should try to make use of as a GDP, as a step 3 in a problem, such as the Grandma Grimm problem or the Little Red Riding Hood problem, whatever it's called. Anyway, all right. You know what I'm saying. Oh, Grandma Grimm was the last problem, or to Hill figure is what I mean. The Hill figure problem is, you go up at 40, come down at 60. I guess I'm just warning right now. I don't think the answer to that problem is 50. I'm just saying. Okay. But you shouldn't be embarrassed or upset if you got 50. And that doesn't mean you should redo your homework necessarily. It just means you should be aware and maybe you'll have a reason to pay attention in class on Monday. All right. Now we're going to start taking some of these concepts and turning them into like symbols and notation and equations and stuff. So from here on, we're going to use X. It says let X equal, and again, I can't see the chat or anything. So if you can't read my handwriting or you need me to go back, please let me know. But it says let X equal, from now on, let X stand for a single point in one-dimensional space, specifically a point on what we might call an X-axis. Okay, in other words, X from now on stands for what we would call a position, a point in one-dimensional space. Sidebar, right now, everything we're doing in physics is in one-dimensional space. I'm not saying we don't believe that there are more dimensions. Right now, we're analyzing everything that happens along a number line. We're acting like we're mosquitoes on the edge of a meter stick or something, and we're analyzing everything that we can figure out about how motion occur in one dimension of space and one dimension of time. So a point on a meter stick or a point on the number line in that homework assignment can be known as X. Now, of course, you could also imagine a Y-axis and you could call it Y or a Z-axis. But the point is we only have one axis now. So we generally, it doesn't matter what we call it, but we generally call it X. Then let T equal a single point in time, specifically a point on a time axis. So the English word for a T value is an instant. The English word for an X value is a position. Notice again, I'm emphasizing these values. So if you say X equals 7 meters or you say T equals 4 seconds, what you're not saying, if you say X equals 7 meters, you're not saying someone traveled 7 meters. That's what I'm trying to emphasize right now. If someone writes down X equals 7 meters in this context, they're not saying someone traveled 7 meters. And if someone writes down T equals 4 seconds, they're not saying some experiment endured for 4 seconds of time. These are not intervals. These are single points. So if someone says X equals 7 meters, they mean that place, 7 meters to the right or to the north or to the up or something from the position known as X equals 0. Like there, okay, it's an address. Just like T equals 4 seconds is an instant. It's not an interval, it's an instant. It's like saying 4 o'clock. What does 4 o'clock really mean? It means 4 hours after what we all regard as our 0 point or our middle point in our coordinate system on clocks, i.e. noon, right? So these values of X and T are literally measurements made in comparison to something designated as a 0 value. That raises the question, what is 0? Okay, so here's the next page. So where is X equals 0? The point, well, it says wherever the physicist chooses, it's a choice. And that's really important to know. X equals 0 is not like an objective value in the universe. There is no center to the universe that all physics experiments like refer to. X equals 0 means the center of your experiment and means whatever you're calling the center of your experiment. It's your choice, but you have no choice other than to make that choice. You have to make that choice. I mean, this is actually, honestly, the tricky thing about physics, honestly. It doesn't seem like it would be, but it is. And it's honestly kind of why we do the whole train of thought thing as assignment 3. Because what we got to start realizing in physics is that everything is a comparison to some choice you make. And it is a choice. That's the power. But the crippling thing is that you have to make the choice. And you have to make the choice clear. And you have to stay consistent with the choice. This is where the diagram at like step 1 DFP comes into play a lot, is that that's where we're making it clear to the world what we've designated as 0 and what we've decided to call everything to the right of 0 and what we've decided to call everything to the left of 0, et cetera, et cetera. And we have to make that clear and stay consistent with it. So everything in one direction from 0 will be designated, because we have this lovely number system with symbols and everything. In one dimension, we have the luxury that in one dimension, there's only 2 directions you can.
Professor, I think we lost you.
One side. As long as we're clear about that and consistent, all of our answers will be fine. Again, that's sort of the point of train of thought. But okay. So that's what X equals 0 means. Then what do we mean by T equals 0? Frankly, I find this slightly more interesting as a question. What do we mean by T equals 0? Well, I mean, it seems to me, I mean, I thought, I don't know what you think, but T equals 0 sounds to me like the Big Bang or something like, or the Garden of Eden. I mean, it sounds like the beginning of all time. That's not what we mean, as it turns out. We can't get our, I mean, we talk, that's not what we mean when we say T equals 0. We mean it's up to the physicist. it's up to you who's doing the problem, or you who's designing the experiment, or me if I'm the one that designed the problem or the experiment. But so specifically, it means when you start your stopwatch, like literally. The whole assumption of physics is that physics is always going on. Things are always moving through space and time. And even an experiment that we set up, there could be looking at some sort of continuing pattern of motion that we're trying to analyze. It might be it's going on before we start, and it's going to continue going even when we end. But the moment we start paying attention, the moment we start collecting data, the moment we start our stopwatch, that is what is known as t equals 0. Okay. All right, so in short, all x values are measured relative to x equals 0. All t values are measured relative to t equals 0. So all x values and t values are relations. They're all comparisons. Again, this is sort of the purpose of the train of thought homework to drum this in, but all x values and t values are but they're all single valued comparisons. They're all in relation to 0. And because 0 is so important, well, I may have to move in a second. Because 0 is so important, we have an extra piece of notation that we introduced that you may have seen in high school, or you may be aware of. And it's called the naught notation. If from now on, so, and I, for those of you who already know all this and are bored, again, I hate boring people, but also part of it, I'm doing this to explain it to people that don't know, but also I'm doing it because truthfully, it's part of the spirit of once we get going in physics, anytime we ask a question, in theory, any next question we ask in physics is derivable, figure outable from everything we originally said. So in a way, just those of you who like heard this before in high school or something like that, don't consider this that right now I'm trying to teach you something. Consider it that right now I'm laying out the rules of our game. Like if you're writing this down, which is good if you are, you're not necessarily just writing this down because it's new information. You're writing it down because it's like fair game for us to refer back to from now on when we get harder and harder questions. The idea should be that any question I ever ask you somehow should be answerable from anything and only anything that we've said before. So, okay, so I'm sort of just building the dictionary for many of you right now, or the axioms, if you like, of like where all this comes from. So it's because it's nothing is supposed to come out of nowhere in physics. It's all supposed to start from things that we all think are obvious, that we all agree on, that we all have intuitions about. And then we start defining terms around those intuitions, and then everything builds from the definitions. Again, it's why the beginning of every physics course is, even to me at this point, kind of a drag because we're just like defining our terms. But it's part of the fairness of the game that once we define our terms, then everything follows from that, and nothing should just be a random discovery like, oh, well, because this scientist in 1700 like noticed blah, blah, blah in a lab, now we all accept that and write it down. Like, no, there's nothing. That's not the way physics is. It's not like that. Anyway, so, and someone's here. Hold on. We'll keep going in a second. How do I get, okay. So back now. Oh, and there is stuff in the chat. Sorry, wait. Oh, and there's me weirdly. Okay, wait. I see there's stuff in the chat that I've missed. So hold on a second. I apologize. Oh, you saw space time and yes, the board as well. Okay, the gravitation. All right, no, I like the jokes. The jokes are really, especially on a day today. I really appreciate the joke. Oh, wait. Oh, sorry. There's a couple of things in the direct chat that are fair that I missed. Hang on. Okay, one person in the direct chat is asking me to repeat something, which I do very much wish to do. I don't wish to leave any of you, except it was at like 5 minutes ago when the person asked, so I don't know what I said to repeat. But of course, if you knew, you wouldn't be at. I was talking about X. Okay. I think I was saying that this might have been the part that every X value, a couple of things. Every X value is a value at a point in space. It's not a difference between 2 points. It's a point. So like one thing I was saying is that if I say X equals 7 meters, it doesn't mean someone walked 7 meters. It means that someone's standing at the position known as 7 meters. And this is the second thing I was saying. I don't know if this is what this might have been the part, but that what does that mean to say the position 7 meters? It means it's the 7th meter. It means it's the position that is 7 meters to the right of a position that we call 0. So this is actually a subtle point. Tell me if this is the part that you want repeated. I'm saying two things at the same time about every one of these x values and every one of these t values. That on the one hand, they are single values. They are like your x and your t value are like your here and now. This is where you are. This is what time it is. That's what we mean by an x value and a t value. They're not how far you got, and they're not how much time has elapsed. Like we have other things for that. And it's important to keep them straight. But they are, so the x and t values are like where you are here and when it is now. But each of those values, even though they're just a single value that's talking about a point in space and a point in time, each of those values is still a comparison. It doesn't mean anything unless we already have previously established what we mean by 0 for space and 0 for time. So bottom line here, this is not, I don't know if I'm exactly repeating what I said, but I'm just trying to expand on it. Bottom line, x and t are coordinates. Like if you think of yourself always in a coordinate grid where like one axis is time and one axis is space, then any dot on that coordinate grid has two coordinates, an x coordinate and a t coordinate. And they specifically tell the whole universe where that dot is and like when that dot is. But it's all only meaningful if we all know where the 0, 0 of that coordinate grid is. I don't know if that, so the person in direct chat who's asked me to repeat, I know that wasn't like a straight up repetition, but hopefully that helped the part that you needed to hear. Let me know. And then there was one other thing that so maybe, okay, thank you. Great, thank you. And you can get many points for that. Awesome, thank you. Then someone else asked something in the direct chat, also very fair. Will we be able to resubmit homework 2 if we got the questions wrong for more points? Okay, the fast answer is absolutely yes. Absolutely yes. And then the slower answer is absolutely yes. No, the more expanded, no, I'm not, definitely yes. But also, I'm really glad you asked for a number of reasons. Number one, and I could see maybe why that was in the direct chat. Like maybe that means that you caught my references to what the answers were. So maybe you're realizing that maybe you got something more to do on it. And that's great. I'm glad you're paying attention to what I'm saying. And honestly, this is why we do the homework. If nothing else, it just means probably I can sort of rely on you to pay that much more attention or care or be more sort of invested in Monday's class or whenever we get to it, when we go over it. So don't be ashamed if you got it wrong. And most people do, by the way. Most people get the last 2 questions on homework 2 wrong. They're not meant to be tricks, but they're meant to like show us something. So you definitely can resubmit for points and get a perfect score on it. And that applies to everybody. And not only can you, but you should wait till we go over it. It's not cheating. If we go over it on Monday and then you get it, so you not only get why you're wrong, but you see what to do that's right, as long as you rewrite it up in your handwriting and with your explanations and you make it clear that you now understand it, that's the best thing anybody can do. And it's the same kind of thing that will happen on exams. Like, I'm really glad someone's asking that. So yes, you can. And that will continue to be true throughout the semester. It's just, it'll be harder and harder without falling behind to keep resubmitting, but you'll always be allowed to do that. And it's also why I'll accept things late, at least right now, because as long as it doesn't put you, like eventually you won't be able to give me things late because it'll just be too hard because you'll be trying to keep up. But anyway, you get my point. So yes, absolutely. Yes. Thank you for asking. All right, back to, we have 15 minutes. Okay. Back to the board. Okay. All right. So from now on, if we ever put a subscript to the right of a variable, such a, I mean, if we put the subscript 0, I'm sorry, to the right of a variable such as x. Well, first of all, the way we read that, like if you see x sub 0 like that, that's read as x naught. Like naught means nothing in like British. So it's we read that as x naught. And what it means, it doesn't mean that x equals naught. It doesn't mean 0. It means the value of x, specifically when time equals 0. In other words, it means the initial or starting value of x. I'm just going to write that in. Hold on a second. Okay. This is a very important piece of notation to get used to all the time in physics. And note again, x naught. If you understand this notation, it doesn't, x naught does not always equal 0. In fact, in this homework 1, in this first problem, if you look at the whole setup and you read it carefully, you see that x naught for this whole problem here doesn't equal 0. It equals positive 4, because when we started paying attention, the instructor was at place 4. And if you really think about it, I'm going to go with another step. Like it says that he went from 4 to -2 at constant speed, right? If you really think about it, there's no way he could have done that. There's no way he could have done that unless we're making the assumption that this professor was going back and forth and back and forth for, or this instructor, whatever, was going back and forth and back and forth for a long time. And then we just walked in the room. And when the professor happened to be at position 4, then we like took a camera out of, in effect, or we started to making a movie of all this, and we started a stopwatch right at that moment. It's actually a really more helpful way to think about physics. You don't think of it as the experiment started at t equal 4. Don't think of it as the instructor started moving there, because then you'll very legitimately start having confusions about, well, wait, if he started there, I mean, then he wasn't moving originally, then he must have gotten up to speed somehow. Like, how did he ramp up from no speed to a certain speed to start moving toward, the negative values? And that's like a very legitimate physics question that we eventually, and it'll start making all kinds of, it means basically that something's wrong if we say he was going constant speed from positive 4 to -2. So the better way to think about physics, unless you're told otherwise, is just think of things as undergoing continuous motion. And t equals 0 is just when we walk in and start paying attention. I don't know that. I remember the day that someone said that to me, and I was like already into physics for like 6 years, and they said it, and it sort of like stopped me in my tracks. Like I don't know. It just sort of, it's a perspective changer for me anyway. But if not for you. But okay, so we now say then that in general, any variable that we use from now on, whether it's x or y or z or a for acceleration or something, or f for force, any symbol that we use, if we put the subscript 0 to the right of it, then we mean the value of that variable at t equals 0. Someone's here. As you can see, we're treating, like right now, we just, in all of our measurements, we just have two kinds of measurements in one dimension of space and one dimension of time. We're going to be building more and more dimensions of space as we go. Sorry, I know we're going to be developing more and more quantities and more dependent quantities to track. But the independent quantity, or the independent variable, I should say, so frequently and fundamentally in physics is time. Time has a sort of special status. So squiggle sub-0 will always mean the value of squiggle at time equals 0. There, now I'm going back to the screen share, or trying to. Sorry, can you see this screen? Can someone? Are we back on the screen or no? I mean, are we back on the whiteboard? Can someone yell?
No, we can't see it.
Oh, you can't. Thank you for your honesty. Okay, I'm glad I asked. Right, hang on. Oh God. Quick interlude here. And you guys are doing well, by the way. I appreciate you putting up with all this. And we only have 10 minutes. Oh, and there is something in the chat. Wait, as long as we're here. You're being very, oh no. That was fast. Okay. So no. All right, I'm getting the screen up. But you're actually moving we're actually making more tracks than in this morning when this whole technology thing really fell apart. So credit to you. But also on this, don't think that the irony of me being a physics professor and yet not being able to operate a freaking device, don't think that irony escapes me. And as a sidebar, I learned from my older, I have two sons who've both had to deal with Zoom school a lot. And, you know, it's like destroyed each one of them in a different way. So I totally get it. My older son, who's 19, introduced me to the YouTube a long time ago, introduced me to the YouTuber named Gus Johnson, who I think has been I think he's canceled like in a big cancel culture kind of way. But if you ever look up old videos of Gus Johnson, he's not inappropriate. I don't think, not his videos aren't inappropriate. But they're hilarious. And just a quick sidebar, he does this one video called How to Be a Professor. Um, and it's all, he walks in pretending to be a professor and basically spends like an hour failing at all the technology in the most awkward, pathetic, but common way. I mean, I think it's hilarious and spot on if you're ever really bored. I don't know. Anyway, and I'm feeling like that right now. Okay. So what am I saying? I'm saying uh from here. Oh, wait, did I? Oh, yes, this thing I wanted to say. So in the mid, oh, can you see the board now? I'm sorry. Can you see the board now? Is it? Could someone just yell? Because I can't see the chat when I can see the board. Can you see the
Yeah,
board?
we could see it.
All right,
Yeah.
great. Thank you. Okay, thank you. Thank you. Okay. And submit those for points for voice points. Excellent, excellent, especially a day like that. Okay. So what it says in the middle of the board now, this is a little weird. Like I'm being very picky here. I'm making a big deal and saying, don't think that X naught necessarily equals 0. It doesn't. Often it equals like 4, like today's homework, right? X naught doesn't mean the 0 value of X, it means the value of X when T equals 0. However, if you could put the subscript on any variable we ever like, and we do all the time, that means that T sub 0, T naught, would by definition mean the value of T when T equals 0, right? Just because T is that special thing that everything is related to. So T sub naught means the value of T when T equals 0. Well, obviously when T, I shouldn't say obvious, but certainly when T equals 0, then T equals 0. So T naught does necessarily always equal 0. That's a little bit important. You'll see in a minute when I develop one of our equations, like T sub naught always does equal 0. None of the other ones do, but T does, but just by definition. So from now on, then, we're going to say that displacement, like all of this is in my long, tedious effort to convert our English into symbols and into mathematics and into mathematical equations. So from now on, the English word displacement, the difference between one position, like now, and an earlier position or an initial position, from now on, you could see why we're going to always denote displacement as x minus x naught. And that takes into account many facts now. Like if we do that from now on, if anybody ever asks for displacement, and we write x minus x naught. First of all, notice, well, I think this is on the next page. Yet notice, like each of those positions, each of those x values, they refer to one point in space, one value. And this is kind of what I was repeating for someone in the direct chat when they asked me to repeat, right? But display, so position applies to a point in space, whereas displacement applies to an interval between 2 points. This distinction is going to come up a lot in physics, just like scalars versus vectors come up a lot in physics. Like it's important to keep in mind whether you're tracking direction or not. It's also important in physics to keep in mind, am I considering the value at a point in time and space? Like, am I trying to figure out some kind of value applying to a dot in a coordinate system? Or am I trying to calculate some kind of value that applies to the interval or the segment or the difference between two dots, 2 points in space time? This is so important. I'm even going to say something here that I did not write down that I think you should write down. The big difference is values at points are more precise and more theoretically computable. Like we have lots and lots of theory, lots and lots of math, lots and lots of analytical. Don't say theoretically, you can say analytically. So point values at points are more precise and are more analytically computable. When we try to figure out how fast something is going at a point, we have lots of methods, mathematical methods for doing that, and they ultimately boil down to calculus. And we can get very precise answers for exactly how fast something is going at exactly like 3:02 p.m. on Tuesday or something, right? But they are just that. Mostly we have to analyze and do math in order to get these precise values. In contrast, values over intervals are far easier to measure and far easier to picture in our minds, but they're generally approximate. So I'm just going to say that again because I didn't write it down and it is important. Like a lot in physics, sometimes we're looking at points and sometimes we're looking at intervals between points. The advantage of points is that they are precise. Values at points are precise and they are analytically computable. We can analyze them. We can use analytical methods like math and equations to figure them out very specifically. But the disadvantage is they're very hard to measure and they're very hard to picture in our minds until we get used to them. Values that apply to intervals are easier to picture, easier in our minds, easier to measure, but they're generally approximate. They're not exact. They're not precise. I mean, they're not they're approximate. They're not exact. So a couple other things back on this definition of so the only like notation. I'm looking at the time. Wait, what time is it? Hold on, sorry. Is it okay? So we're gonna end in 2 minutes. All right, so I'm just gonna go. So we did all that. All right, so sorry. So I know we have like 1 minute left. The thing I really want to say now then is here at the bottom of the sheet. If displacement from now on means the difference between two positions, and it means any two positions, right? Like some textbooks and some websites will say x final minus x initial or whatever. I just say x minus x naught because remember, x naught refers to the position at the beginning of some experiment, and the beginning of the experiment is up to you. As long as you're clear and consistent, you can even shift your perspective from one segment to the next in a multi-part problem like this one. Like you could keep restarting your stopwatch, right? So x minus x naught means the difference between something now and something earlier. Average velocity. So look, I'm looking at the bottom of the page. This is the last thing I'm going to write. This is like our big equation that we're going to use for the rest of our lives now. I'm saying if you take an interval of space and you just divide it by an interval of time, it's just like the simplest possible way that you could put together our two regions that we're ever measuring. Like we're measuring motion through space and time. So if we just ask ourselves, how much of a chunk of space did we get through in how much of a chunk of time? If we just examine that ratio, it's the simplest way we can examine the relationship between space and time. We call that ratio average velocity. Notice it's a totally balanced fraction. It's x minus x naught over t minus t naught. But because of everything we just said about how the naught notation works, t naught always equals 0, so we can always cross it out. So we don't generally put it there. But I just want you to see that average velocity, the definition of it is we're just defining a term to be the simplest possible correspondence or ratio between an interval of space per an interval of time. And because of the way our notation works, we don't have to write out the T naught every time. So that is our first and foremost equation that we'll use for the rest of 2 semesters. Remember, please, as I know we're leaving right now, no class. So remember, please, it's a definition. So when in doubt, any problem that you have from here on in, any problem that you think you don't know how to start or you're not sure what to do, your first GDP for any problem or any homework from here on in should first be that. You might not think that you have all the information right away, but if you think hard enough, it might turn out that you do. But that equation, even if you don't know how to use it right away, is always true. because it's a definition, it's like the master of all GDPs. Okay, I think that is class. You've been very patient, be very indulgent. I'm going to let go of the screen so I can see you. You can go. I'm sure it's time. I'm going to hang out though in case you have any questions or whatever. I'm going to post this PDF, of course. I'm going to stop the recording. I'm going to try to post this recording, but I can't. I'm just going to cross my fingers on that. Hold on. I'm going to stop. Okay. And if you're already gone, I totally understand. But if you're not, let me just look at the chat. But I'm still here, and the recording I'm turning off. So I'm waiting just in case anybody wants to ask any questions.